Hey guys, so by popular demand I'm going to be doing a couple of videos on solubility. However, I'm kind of pressed for time at the moment, so these might be a little bit rushed, but hopefully the short amount of videos will still be pretty thorough. Okay, so first one, it's pretty basic. Find the concentration of the ionic species in a saturated solution. So okay, how do we do this? Well, we always just start with your formula. So in this case, we have our Ag2CrO4, and it's going to be dissociating into 2 molecules of silver and 1 molecule of CrO4. Okay, so that means for every molecule of our Ag2CrO4 that dissolves, it's going to yield 2 molecules of silver and 1 molecule of CrO4. And that ties into our KSP. So what does KSP equal? Okay, so KSP is just like any other equilibrium constant. It equals products over reactants. So we have products 2Ag and CrO4. So let's write the concentration of Ag, and because it's 2, we're going to square it, just like always. And then we have CrO4, 2 minus. I'm going to leave out the charges when I'm doing this, just for simplicity's sake. Okay, and then this is over our Ag2CrO4. However, this is in the solid phase, whereas these two are aqueous. And we only really care about the aqueous. Solid, well, concentration of a solid is kind of hard to assess. So we just leave it, the KSP, as this. Alright, so how do we use this to find out the equilibrium concentrations? Well, okay, we're going to start with all Ag2CrO4 again, and that's going to dissociate into 2 molecules of this. But because you can't have either silver or CrO4 forming spontaneously without the other one forming, we can relate the concentrations of Ag and CrO4. So it should be pretty obvious to say the concentration of Ag will be twice the amount of CrO4. So if I let CrO4 equal x, so CrO4 equal x, Ag, because there's going to be twice as much of it, must equal 2x. So we're going to throw these into our formula. So more KSP equals, which is 1.1 times 10 to the negative 12, so 1.1 times 10 to the negative 12 equals, so Ag is 2x, so we have 2x squared, and that we have CrO4, which is x, which gives us, what's this, 4x cubed. Okay, so then all you do is take your cubed root of 1.1 times 10 to the negative 12. Sorry for getting a little bit small here. Divided by our 4. And that's going to yield, okay, let's see what kind of number we get from that. We get 6.5 times 10 to the negative 5. 6.5 times 10 to the negative 5. Is that right? I guess I wrote this on a piece of paper. It's kind of messy. I'm just going to redo this really quick just to see if that number's right. So divided by 4. Yep, it's times 10 to the negative 5. Okay, so what does X tell you? Well, X tells you the concentration of CrO4, so we can say the concentration of CrO4 equals this. 04, I'm going to put in the 2 minus and the concentration sign equals that. However, the concentration of silver ions is going to equal 2 times this, so we have 2x, which just so happens to be 1.3 times 10 to the negative 4. And these are, of course, in units of molar. Okay, so that's a pretty basic one. You'll see everything else based in solubility based off of this general equation right here. Everything uses this, and it's just a manipulation of it. So we'll do another example, I guess.